Okay, so next we're going to talk about the rational zeros test. This is also called the rational roots test. It is also referred to as what you use to find the possible rational roots or possible rational zeros. So all of those things are referring to the rational zeros test. So this is what the rational zero test says, or what it is. So if polynomial f of x, and remember this right here, this is just our generic form of a polynomial, so that we've seen before. So if polynomial f of x has integer coefficients, so it's very important that it has integer coefficients, every rational zero of f, so every rational zero that occurs from f, and f could have no rational zeros, keep that in mind as well, but if it has any, they will be of the form p over q, where, so hold on, I know you're like, well, what the heck is p and what is q? So where p and q have no common factors other than 1, and p is a factor of the constant term a sub 0, and q is a factor of the leading coefficient a sub n. So, if polynomial f of x of this form has integer coefficients, every rational zero of f has the form p over q, where again, p is a factor of a sub 0, and q is a factor of a sub n. So now I want you to try to kind of put that in your own words, because that's a very formal way of writing it. It's correct, but it's very formal. So try to rewrite that in your own words. Pause the video. Unpause when you're ready to move on. Okay, so for the next example, the first part is to actually list all of the possible rational zeros. Then you're going to find all of the zeros, state the x-intercepts, and write the function in completely factored form, which is the same as saying as a product of linear factors. So first, let's do the possible rational zeros. And so what the rational zero test said was it's all the factors of the constant term. So what are the factors of 9? Well, the factors of 9 are 1, 3, and 9. Now, keep in mind, there's also negatives as well. So negative 1, negative 3, and negative 9. So I'm going to write it like this. Plus or minus 1, plus or minus 3, and plus or minus 9, divided by all of the factors of the leading coefficient. Well, in this case, the leading coefficient is just 1. So the factors of 1 are 1 and negative 1, though. So I'm going to do plus or minus 1. So then I'm going to expand this out a little bit, and we'll write this as, if I do 1 divided by 1, that's 1. So plus or minus 1, plus or minus 3, and plus or minus 9. By divide, and what I'm doing is, again, this is a little bit simpler because the denominator is 1, but if I had more denominators down here, more terms in the denominator I should say, I would have to do each combination of the numerator divided by the denominator. So this is how I would list the possible rational zeros. Okay, now I want you to complete the rest of the problem on your own, because you should be able to do this since we have done many problems like this. So I want you to find all of the zeros, all, not just the real zeros, state the x-intercepts, and then write the function in completely factored form. So pause the video, do that, unpause when you're ready to check your answers. Okay, so we should end up with all of the zeros, or the zeros, are x equals negative 1, x equals 3i, and x equals negative 3i. The x-intercept then is the real zero, which is negative 1 comma 0. And then the linear factored form, or completely factored form, is f of x equals x plus 3i times x minus 3i times x plus 1. I found the zeros in this case by just factoring. I factored by grouping. You could have done synthetic or long division. You could have done or used the calculator. There are many ways to find the zeros. Okay, so remember, possible rational zeros or possible rational roots are the same thing, and we find them by dividing all of the factors of the leading coefficient and all of the factors of the constant term, or specifically the factors of the constant term divided by the factors of the leading coefficient.